Hi, Jose. How are you doing? I'm good, thank you. Do you have any questions for me regarding the stuff um that you missed the first day or? Hi, David. How are you doing? Okay, good. Let me know if you have questions. Okay, you're welcome. We'll wait a few minutes for everybody to jump on. I updated the lab document. I fixed some of the issues, and then we'll talk about, I added the servo motor basics to the last exercise. So if you want to check out lab document, and then we'll talk about the things we have to do today. Hello, Claudia. How are you doing? Check out the new updated lab document. We'll work on this stuff in a few minutes. Okay, cool. In the meantime, you can check out the lab document and then get out your Arduino and the parts. And then we'll get started in a few minutes. When everybody get on, we'll wait a few minutes, okay? Well, we're halfway there as of today, and then we have next week. So we're gonna be using RGB, the clear bulb, the LED bulb that has 4 prong. So if you want to take that out, you will also need potentiometer. It will be like that with the knob. Hi, Ghislaine. Hi, Kevin. We'll start in about a minute. I think Hannah is here. Hi, Hannah. We'll start shortly, so take out your Arduino. I also changed the lab document a little bit. So if you log on to Canvas, you will find the updated version. Okay, it's 2 o'clock. I'm going to go ahead and get started. I think a few people might be jumping on shortly. So we left off with a few things. I think some of you were having challenges. I know many of you have done the last part, which is when we created the theremin and then with the LED. So what I did was I redrew the diagram with the LED included because the code actually had the LED. So instead of, you can uncomment it if you want it to work, okay? So I'm gonna go into screen share, and then I know that seeing the camera in the screen sometimes can be challenging virtually. Um, So I changed up the lab document a little bit. For the theremin, I updated the drawing with the photo cell. And so now we, because I noticed that in the last few exercise, you notice that when you unplug the ground, it works. It's because you already have the ground loop. Um, so in the case where if you have the ground loop, then it would be efficient to not having to use the ground, and you would see that for the subsequent one as well. So what I did was I added the LED and I tested it. So what happens is I wanted to plug it in so you can see. Um, the code actually calls for the LED. So when you plug in the LED, let me take this out of, okay. You hear it now as I have light in the room. So when you plug it in, the LED is only gonna turn on the first time. And once it finished calibrating, it's gonna stop. Okay, so it's not designed to really blink the LED. It's for the code itself, it's only designed to actually turn on the LED and be able to calibrate and then stop. So that was the main difference in the theremin, in that, in the old diagram that I pulled from the actual exercise, it didn't have the proper LED connection. So I added that and I redrew the diagram and I tested it. So with that, it would turn on the LED at the beginning and then it stops once it finished calibrating. Now, when you would see that when you put your finger over it, right? The tone change. So that was the whole point with theremin. It's not 100% like a regular theremin, but it's close enough. Okay, any question? Okay, so I updated the lab document with that, and then the code is still the same. So now after that, some of you did the LED separately so you can have a better understanding of the photo cell. Now I was going through the part list box, and in your book, in the Arduino kit, if you take a look at the book, it listed all the parts that you have in your kit. So parts in the kit page is on page 6 of the book. So in the case where if you don't know what part you're looking at, you can flip through those pages in the Arduino kit book, okay? So, and then I started noticing that they gave you a photo cell, but it's a slightly different than the one we've been using, um, which is, let me unshare my screen so that way we can see the picture. So it's like this. It looks almost like the RGB, but it has only two legs. It looks like a regular LED. It has a flat top, okay? And notice that this one, the legs are different than the other photo cell. The other photo cell, you have the same length leg. So this one, it shows there's a shorter leg and a longer leg, and very similar to what you see with the LED. You would be able to use it just like how you would plug in an LED. So this is the photo cell that comes with your kit. Okay. Now when I tested this, um, I didn't like it. I felt like it's not as sensitive as the other one. But if you have some time, you can check it out. You can play with it. And then I know that there are activities in the book that has photocell. So you can refer to those activity if you want to expand your skill a little bit. All right. Any question? Okay. So next we're going to touch on the next part. So after this, right, make sure that you take pictures of your circuit once you got it working. And then every time that you unplug and replug your Arduino back in, make sure you check your COM because your computer is going to want, especially the Windows PC, it's going to want you to verify that. Okay. So now we are going to move into using potentiometer, and we're using the RGB. Okay. Um, Keep in mind that when you're putting the resistors in today, if you're using like 270 instead of 220, your LED is going to be very dim. I know that the resistors that comes with your kit, sometimes they don't have all the resistors that we might use. You might use something close to it. So just want to let you know. And then if it's not showing the light, just check your connection. That's important. So we are going to build a circuit. We've been working on RGB, which stands for red, green, and blue. You've seen this already, your common node. And so your LED, we are going to use the variation in the colors to display, and we're going to try to simulate what we would see with the night light. Okay. So if it sends certain light, right, it's supposed to change the way the brightness of the RGB, how it's going to be. So you're going to see that we are going to use the potentiometer to adjust it, like how you know how you use ambience light at home. Sometimes some home comes with a knob where you make the adjustment. So that's what we're going to be doing. And the potentiometer that comes in your kit, okay, is slightly different than the one that I captured the picture. um so 1 second. So it is this one. It has a hole in the middle and it's blue and it's square on the top. And then if you look on the bottom, it has three prong. It has three legs. Okay. And come with it would be a white knob, and it looks like a button and it's long. So what you do is you take that knob and you attach it to the top. And on top of that knob, you would see an arrow, and that arrow is going to indicate the direction. So this potentiometer itself, right, very similar to, so I transition you from photocell to this is because itself is a form of resistor. But what we want to do, instead of the regular resistor, this one is a variable resistor. So it, it is an analog base, so you can make the adjustment when you turn the knob to the left or the right. Okay, so that's what we're going to be using. Sorry, let me come back to my document here. So now there are variation in the potentiometer in the market. You might find some of them similar to what you have in the kit, but in black. Sometimes they're in metal, but they usually have three prongs, either three prong like what you have, or three prongs in the same location. It will be on the same side. But those three prongs are significant because they are different, right? Each one would mean something. So what we're going to do is we are going to plug the potentiometer in, and we're going to use it to adjust the value, the analog value that's going to be for our RGB. Okay, so when that happens, what you have is you're going to have a varying amount of resistance, and so that's going to be passing the voltage through the potentiometer, and it's going to be analog input onto your board. Okay, so instead of having the digital input, we are using the analog input, and we can make the adjustment simply by just twisting or turning the knob. Okay, and as we touched on before, we talked about PWM as we touched on RGB at the beginning. But what you have is, before we see that, we would give it either 5 volts or 0 volt. What if we want something in between? What if we want 2.5 or, less than 5 volt? So a way that we can do that is we would use some kind of analog control to be able to do that. And this is when we want to introduce potentiometer. Now the picture that you see in the diagram is going to be a red board, and the red board is just another manufacturer version of the Arduino. Okay, so it uses the exact design and the diagram for the Arduino. There's some slight difference in and minimal in some of the traces, but you would see that it would have similarity with the Arduino. So what works on the Arduino will most likely, right? I say most likely because there's a slight difference, work on the red board. Okay, so the potentiometer, sometimes you see it like this, sometimes you see it in black, sometimes you would see it in metal like this. I bought something like this before. It's a little bit different when you're hooking this up, so you're gonna have to use a clip, or you can solder the wire onto it if you want it to be, or you have to use some kind of copper to attach it. As long as it's conductive, it's able to transfer that signal. Okay, so here it talks about using the analog right. That's going to give you the voltage between 0 and 5. Okay, compared to what we've seen with the digital right, that's going to either be on or off, right? Off is 0 volt and on is 5 volt. So we would have a little bit more variance in how we would use the analog. So for this exercise, you're going to need your Arduino, your USB cable, your breadboard. You're going to need the 4-prong LED, which is your RGB, okay, or sometimes they call it the LDR. You are going to need 3 220 ohm resistors. Now, if you have the 270, you can use the 270, like I said, but keep in mind that the light is going to be slightly dim. You are going to use a 10K, like what we've done in the last couple exercise for the photoresistor. And you're going to need a few more jumper wires. Okay. So we are going to use mostly male-to-male jumper wires. And then you're going to need one potentiometer. That will be they come in two parts. So take the white knob out of the big bag for the electronic components. And then you're going to need the square blue bottom, and you would attach them together. And the white knob should have a little arrow at the top. Okay, so those are the things that you're going to need for this particular circuit. Any question? All right. So for the RGB, we wanted to spread out the leg, right? And then we want to plug it in with the flat edge to the side of your breadboard. Okay, so the red is on the other side. Okay, so when you plug the flat edge in, the flat edge is going to be opposite from the red. So the red should be over here. Now the resistors, the three resistors, the 220 ohms, those are going to line up with the legs for your RGB. Except for the common or the ground, that's going to be connecting to the ground. Now I put a little note here that you don't need to connect to the ground connection on the board because you're already looping the ground. So on this one, you don't need that. Because if you plug it in, you will likely find that it won't work. Now, my advice for you when you plug this in, okay, I'm going to stop share for a second because you also see this document. When you plug it in, put your potentiometer in the middle, right? It's going to, just like how we used the button before. So you need to put, there's like a middle groove on the breadboard. You are going to put your potentiometer above that groove in the middle. Okay, because if you do it like the diagram, you will find that you cannot plug your wire in right adjacent to it. So if you want it next to it, you can move it into the middle above the groove like this. Okay, and then sorry, the middle one, the middle leg, you know how you have three legs, right? Three prongs. There are two together and one in the back. That one in by itself. That one is going to be for ground. So, and the other two are going to be for signal. So what you have is you need to have that one leg right next to your ground cable. Okay. Any question? So what I did was I put the photo cell over here, my potentiometer over here, and then my RGB over here. Okay, so if you have a longer breadboard like what David has there, it's probably you can and it also depends on your cable too, right? Your wire. And so the resistor, the 220 ohms, that should be lining up with the legs for your RGB. So I'm using different manufacturer resistor, so that's why it's blue. On yours, you might have the lower ones that might look like a tan. So you can take a look at the stripe on it. Okay, if you can find the 220 on your resistor pack, you can take that out. Okay, and then the photocell, the resistor that goes next to the photocell is going to be your 10K. Okay. Any question? So I don't know if you can see it. I'm moving in the middle right here. Okay. So you see that? So how it is pulsing different color. Okay. So now if you don't see your pulses of color, it's because possibly that your connection is wrong. If it's not even lighting up, that means you need to check your circuit. Okay. I should move my wire a little closer to my. So now, once I turn it on, what I can do is I can try to turn it. So I now have a little bit more red before it comes off. See that? So you can try to adjust the knob to see if you have, and also your photo cell, if you cover it and then turn it with your other hand, you can see the color changes, you know? So you can play with it a little bit and see. Okay, so I show you how you can test that. Okay, like I said, potentiometer should go in the middle right here, so that way it's easier for you to plug it in. So the red board is made by Spark Fun, and like Adafruit, Spark Fun also produce their own kits and components. Okay, many manufacturers produce that, but Spark Fun had quite a few branded kits. And you know, compared to the Arduino, Spark Fun breadboard is not as common, so you do see some project on their hub, on their website for that, some tutorial for their own breadboard and their own kits. They have different type of boards, so they have small ones, big ones, something similar to the Nano and something similar to the Pi Zero. Okay. So while you're building your circuit, I'm going to touch on a little bit on the code as you will be putting this into your Arduino IDE. And remember what I said, whenever you plug in or unplug your Arduino, if you wanted to upload your code accordingly, make sure you check your COM port setting, okay? So we declare our variable first, and that's always important when you start programming your Arduino. You need to set up your variable, you declare your variable. And the two things that are using analog are A1 and A0 are the photoresistor and the potentiometer. And in this one, we also set up a threshold, okay? And that's gonna be in the condition. So if it reads below that value, the light will turn on. Okay. Like for night, when it gets dark, you want the night light to turn on, right? You've seen a lot of electronic night light like this, where you can put it in your room and it automatically changes color as it turns on. You can adjust the color that you want. After we declare those variables, we still have to declare the pin for our RGB, right? So in this one, we are going to connect the red pin to pin 9 and the green to pin 10 and the blue to pin 11. And LEDs are on the digital side, so you just simply use those pins. Then in void setup, we have initialized the serial monitor by doing serial begin. And you want, the standard is to use 9600 baud. And since we're using LED, we have to set up the pin mode. So we want the red to show, the green to show, and the blue to show. Okay. So we are doing the next part of the lab. This is going to be the RGB with potentiometer and photocell. So after we had set up our serial monitor and our RGB output, we would then go to the loop. Okay. So you want to use analog read here for your photoresistors. So that means that when it sends, less light, it's going to store that value to the variable photoresistor. We have 11 wires in total connected since the ground won't be included. Yes. Let me count it just to make sure. 2, 4, 6, 8. I have 12 because I use one to bridge between the potentiometer and the ground. So it should be 12. Okay, so we talked about how it's going to read the light value, right? The sense light value, and put it into the photoresistor. Then it's going to also read the value as you turn the knob. Okay, that's going to store that into the potentiometer. Did you include the wire between? Yeah. Double check 2, 4, 6, 8, 10, 11. Hannah, you're right. It's 11. I miscounted one of the black. 2, 4, 6, 8, 10, 11. Yep. Sorry, 11. And 11 includes the between the resistors and the bridge. Okay, so also we are going to do a serial print. So in this one, you can actually turn on your serial monitor, or you open it. And so when you, after you upload your program and the light is blinking and as you test it, you want to go to tools and then open up your serial monitor. Okay, let me close the Theremin one. Here's my nightlight one. So you would then, let me re-plug it back in. Let me get the Theremin out of the way here. So this is the one that we're working on. Okay, so we first need to check our port, and then we're going to upload. Okay, and then if you don't get any error down here, you can test your light. So then you're going to open up tools, and then you are going to look at the serial monitor. Okay, and it's going to take a second, but it's going to tell you the value. See how it's variance, and then you can try to turn the knob, cover the photo cell, turn the knob, and so on. Okay. If you don't do anything, it's just going to be constant like that, 1023. And then you can test it by changing the knob so you know your potentiometer works, and then cover your photo cell, and so on. Okay. So this part of the code takes care of the output. And as you can see, when you print, this is a string. So you would put it in the quotation mark, and that's being passed inside the parentheses there. So that's passed in the parameter. No, okay. So good question, Hannah. I forgot to mention the beginning part about Spark Fun. That's just a block comment. It's going to ignore that when it compiles anyway. So you don't have to add that. Okay. I only included that so that way you know where I got the exercise from. So if you wanted to go check it out, you can. So at the top, you would see in the code that I included, you see the block comment, and how we comment in C or C++. Single line comment uses the double slash. A block comment, you can put like a paragraph. You would use a slash and an asterisk. Okay. So we mentioned that in the parameter here, we're using a string, and you wanted to include that in the quotation mark. And then and on the last one, you want to bring down the value from the potentiometer. So if you turn the knob, right, it's gonna change the value from 1023 to a different value. So you want to display that. Okay. And then we want to print that. Then we also have an if statement. This is when we implement the condition. So if it's dark, right, below our threshold, which we assigned a value earlier in the program, it's going to turn the LED on. And then we wanted to nest it. So then we also have another if the potentiometer is greater than 0 and it's going to be less than or equal to 150. So as you turn it, right, it's going to try to sense that. It's going to give you more of the red color. If it's greater than 150 and less than 300, it's going to give you the orange. Okay, and these are the functions that we later define. Kevin asks, how come in the code under void loop we have serial print? The photoresistor value, we use serial print. While for when we want to print the line potentiometer value, we use serial print line. Yeah, so you want serial print line because it's going to include, it automatically include the new line carriage. So that way it drops it into the next line, where if you just do serial print, it will print everything in the continuous line. So in some cases, if you want lines to be more separated, you would do print line. And it's pretty standard for C language, you know, Python and, you know, C, C++. So yeah, so it's just, you still achieve the same thing, but when you have, like, let's say multiple strings, we want them, you know, how you want it to look is really important, because if it's all clumped together, it can be really hard to see. Okay. All right. So for the, when it's greater than 300, so between 300 to 450, we're going to give it yellow. And in this one, you notice that the if statement, we are using two area of the conditions to indicate the range. So, and you're using a logical operator, and this is the ampersand, right? The double ampersand, it stands for and. So the double ampersand indicates that this and this, so it has to meet both of the condition, right? It has to meet this condition and this condition to make it true. If it's true, it's going to give it red. Now the and is different than the or, in that in the or, it only has to meet one condition. So when you're using a range of number in an if statement, you can do it this way, right? You can have an ampersand. So we can say, if the value is greater than 0 and if it's less than and equal to 150, right, we're going to execute this. This is another function, which is red. We later define this in the program. So all function definition goes on the bottom. And so we specify the color based on the range that we want. So we start with red, then we go to orange, and then yellow. And then when it gets higher than 450, we are gonna, when it gets between 450 and 600, we're gonna bring it to green. And then when it is 600 to, when it's greater than 600 and less than 750, we're gonna give it cyan or cyan. And then when it's larger than 750 and less than and equal, less than or equal to 900, we are going to put blue. And then when it's greater than 900, it's going to be magenta. And you likely would see like red or green or, pulses if you have light in the room. To test this and be more realistic with it, we would then have a dark room, and then we would gradually, you know, introduce light and also change the potentiometer. Okay. Any question? So this one really encapsulate a lot of the few things that we've been doing, right? So I wanted to use a project that you can tie in all the other sub projects that we've been doing so you can see a bigger picture. You know what I've also seen people done? They've used Arduino kit for their computer cases, because computer case, it's when you build a computer, you would have some kind of power supply for it, and the case would connect to the power supply for, you know, lights, USB purposes, and so on. So what you would have is you can actually include a microcontroller like this to make your case look fancy. So if you look at like some of the RGB kit that they sell for power for your computer case, all it is just a programmable RGB that's already there, and it's being powered by your power supply. Okay. So now you can be creative and you can think about, oh, well, if I want to buy a computer, I can make it look different than what they have in the market. Okay. And you can even have motor, and, because to really drive the Arduino is very low voltage anyway. You don't have to tap into the power supply. You can use like a rechargeable battery or something like that, or power bank, things like that to really get it to work. Okay, and so after the nested if statement, we would then have the else. So if it didn't meet any of the conditions, then we would have it turn off by defining the turn off function later on. So here we're going to call on that function turn off. And the delay in this, you see that it's fairly rapid. So because it's 100 millisecond. So if you wanted to slow down a little bit, then you can change this value. So since we use red, orange, we call on the function, we would then have to define it here. We would have void red, and then we would specify what that means, right? We turn on the red pin to 100. In the past, you did 255, that's full pulse, right? This one, we are going like a little bit less than half pulse. So it's going to be 100, and then turn off the green and the blue. And then you can mix for the orange. We would do 100 for the red with 50 for the green. And then the yellow, another function. We would do red and green at 100. And then for the green, we only turn on the green and the other ones are off. And then for cayenne, we would do 0 for the red, off for red, and then 100 for green and 100 for blue. And I think we have magenta or blue. So blue completely on for the blue. Magenta is when we do red and blue. So if you want something like purple, then all you have to do is to declare that function, right? Specify how the analog write pins would be, right? The value that would yield purple, and then call on that function, right? And that has to be done earlier on. Okay. And then since we call on turn off for the else, we would then have a function called turn off, define that here, and then we would have all the pins off. Make sure we have the enclosure curly brace, otherwise it's gonna throw an error. So as we wrote out our code, we're gonna then save it. I normally give it a name. I do save as, and I save it so that way I know which one is which. Otherwise, it's gonna default to your sketch for the time that you save it. So it'll give it a date and a time. And then, you know, a while from now, you look back, you're like, what did I do on that one? And then you have to open up the code and see. And by just reading the comment, you kind of have an idea, right? This is a single line comment. You have an idea of what's happening there. So after you upload your code, you would then open up your serial monitor and play with your circuit by turning the potentiometer knob and see if you have different values showing. It's really hard for human to really detect the slight change. So the point in this is so that way you can see that it is a variable resistor. If everything works accordingly, take a picture of it for your lab submission. So here it walks you through the procedure, right? The steps for the program. And some of you took my classes before, so usually this is what we would start with, which is pseudocode, and then we would then break it down. So when you think about, okay, well, I want to make an Arduino project, have a goal in mind and then take that goal and break it down into the steps, so that way you can pseudocode it, you can write down the steps and then fill in what you have to do with, you know, the resistors, all of that, and then how you would build the circuit. Okay. Any question? Okay, so I'll give you a little bit of time to get everything put together and test your code. And let me know if you have any questions. So if you missed earlier, you know, I mentioned that in your part box, there is a photo cell that they included in the Arduino kit. It looks like a white LED, but it has a flat top and it has the two legs are different. So applying what we've learned from, you know, which side is the ground. And so this is, you know, you can also use something like this, or you can use the one that they gave you. You can also refer to the book It's on page 6. It lists all the parts starting from page 6. So if you know what part is this, because that bag has a lot of different parts, so you can find that on the pages um, in your kit, what you have, and so on. It's really geared for the exercises that are in this book. So if you like this exercise, you wanted to do other exercises, you can go through some of these too. Or and then also if you're using resistor that are higher than 220, which sometimes, you know, it comes with this pack, and if it's you can't find a 220, you can, it's gonna be dim, so that's okay. And if it's super dim or it's barely pulsing, check your connection. So I bought a kit by Rex Quails. It comes with the Arduino. It's the basic kit, and it has LED and everything. Let me show you the box so you can see. I got it a while ago, but you know, with Prime Day, not the last Prime Day, but it would look like this. And then in it, you have mostly everything you need. And the cool thing about this kit is that they give you a lot of different wires instead of the tiny baby wires. Um, and the resistor, you know, it has the label on the top. So each of the section, you see how it says 220 there, it actually has that. While the resistors are labeled, I felt that, you know, their resistors are kind of, the metal leg is kind of thin, but it still works. It does its job. Okay. And then it comes with like a little CD that you can use to follow their, who use CD and DVD these days now, right? But I think you can go to their website and you can also check out their projects, and it has the breadboard and everything. So I think I pay like, before, you know, processor had gone up, I think the price might be a little higher for kits like these, or Elegoo has some good ones too. But I think I paid like $12 for this on Prime Day last year or something like that. And I bought like well over 50 kits with my own money for my students before. And so when they told me to clean out my office for COVID and so they can clean everything, I brought everything home. And so here I am with all the boxes. Okay, so if you like this and you wanted to build out robots and stuff, it will be good to kind of have a little bit of your own kit, and you can just customize it and do things with it. And you know, for to me though, every time that I work with Arduino, if I build a project, I always learn something new about it, something that I didn't pick up on the last round. So it encouraged me to really learn, you know, just even different approach on how, you know, how to program certain things or how to build the circuit better, um, things like that. Okay. Now the kit that MVC bought, the Arduino kit, while it comes straight from the Arduino people, um, it's genuine Arduino, I guess. But it has a lot of great projects and components. The box is pretty flimsy, so when you handle it, sometimes it tears. And then, you know, it's limited to, all kits are limited to what they give you there. So sometimes you have to buy additional components if you need to build out on that. But that when we bought that bulk, I think they gave us the price of $100. I think it's more now. I think it's well over $100. So and we got discount because we bought a bulk as an education account. So you would see a kit like that would go for at least $100 easily. And you don't have to get Arduino brand. You can get other brand, and you will have actually more components for the money with less, right? Less money. Oh, okay. So you getting an error potentiometer. Did you declare that at the top? So Hannah, that is an error because you might have missed a line. Make sure that this is in there for A1. Sorry, I forgot to click the share option there. Make sure that you have this in there. Okay. And the A1 should be connected for your potentiometer wire. Okay. So make sure that we have these variables at the top. And then when you test it, you can go and open up your serial monitor. Let me drag it over here. And then you play with it. Turn the knob. Check out your light. All right, cool. My connection is a little loose here, so mine is not lining up. Looking at the serial monitor, both values hover over, even I cover the resistor. Yeah, so likely um, check your resistor for your RGB and the connection for it. I had, and don't use the ground to the board. If you connected the ground to the board, you should remove it. Okay. And then we need the 5 volt to give it power. So when you check, make sure that when you connect, connect the two for the two wire that goes to the analog behind the two leg of the potentiometer. Okay, not in front of it, because it's not going to work well that way. And then for just like what we did yesterday, so the resistor is for the photocell is going to be lining up with one of the leg, and then the other wire is going to line up with the other leg. The wire is going to line up with the other leg, and that goes to the positive, okay, the positive side. And then for the other side of the resistor, the 10K, this goes to the negative, which is the ground. You see my black one there, okay? And then next to it, I have it connected to the what is it? A0, and then the A1 is for one of the legs for the potentiometer. Okay. I try to use the same color wires so I don't mix them up, like which one is positive, which one is negative. And then for the resistor side, make sure that you line up. And if you're not, so the red is the far, if you're looking at it from this way, it's over here. Okay. And then, I'm sorry, the red is this way, and then the brown is right in the middle next to it. So you can use 270 resistor, and they're kind of close together, so make sure that they don't touch. Okay. Any question? Good. I see Alex. How are we doing? Any issues or any question? The motor is pretty fast, so we should have quite a bit of time on that. So this one's a little harder.
Mine didn't have any issues with uploading, but it's still not turning on.
So I think first your light resistor, yeah, I guess you can have it there. I think you're missing wait, is that a ground? Yeah, I think you're missing a ground. Okay. You see where the orange for the middle next to the potentiometer, that one needs to go to the ground, which is you need to plug the other end of it to the ground of the breadboard.
Okay, thank you.
Yep. Any other question? Okay. Let's see. I'm gonna give you a little bit more time to wrap up that one. And then we'll work on the servo after this. Okay, my code is all good, but I'm still struggling to understand the board. I might be misunderstanding the ground wire. I shouldn't include. Yeah, okay, so like what you had seen in the last one when you did the happy birthday one, right? Um, what you built here is, see how you have this to the ground and then also this is to the ground, and we don't need this because we have the ground looped already across these devices. Okay, um, you are connecting here and you're connecting here and you're connecting here. Okay, so on this is the blue side is the negative side and the red side is the positive side. Okay, and then your components is connecting in the middle. So when you're connecting this to the ground or the negative side or the aisles here, okay, along with this one and along with that one, what you have, and so what you have is you created what they call a ground loop already. So with that, you don't need to have an additional ground connection to the board. Okay. Now on this one, since it's gonna send whatever that's here to this, yeah, we don't need that extra cable there. Okay. But you do need a positive side, which goes to the 5 volts, so it's gonna get electricity from there. So just to clarify, okay, your components to the negative right here is for ground already. Okay, so if you have your board flipped the other way, make sure that you put it in the column where it says negative. Okay. So for mine, I had see all the black, oh, except for that one is a blue. That's going to go to the edge for the negative. Okay. And then the positive, this one, this red goes to the 5 volt. Okay, so I'll start the other one in about 2 minutes. Any question? So if you don't finish this today, you can work on it, tomorrow. You can turn it in by Sunday. That's fine. I just want to walk you through it so you know what to do. If you finish today, you can turn in everything.
Um, I'm not sure if I'm understanding correctly about the grounding, but for the potentiometer, the two legs, one of them is going to connect to the negative and one to the positive, and then the one that's by itself is the one that connects to A1, right? If I'm
No,
understanding correctly.
the A1, Alex, is, so I have, let me show you. I have the A1 is here next to the positive. Okay. The two
Oh,
leg
okay.
together. Yeah, and then the ground is the one, the leg by itself.
Okay,
And
that
that
makes.
needs to connect to the negative.
Thank you.
Uh-huh. Any other questions? Okay, so I'm gonna unplug my RGB potentiometer circuit and Arduino. And then I'm gonna plug in. So I want to show you there are two options to do this. And actually they all, so I had, let me get this cable. This Arduino. Ugh, damage my board there. So I can show you two options for the next one. So to continue from what we had done with potentiometer, before we share this, let's stop share real quick. Included with your, oops, I have it upside down. Included with your kit is this box. It says servo motor, DC motor, starter kit inside the Arduino kit that they gave you. Okay. When you open it up, you're gonna see a black servo, the SG90. And this blade is not attached yet. It's just by itself with no blade like this. Okay. Now you can screw in the blade, but you don't have to right now. So if you don't have a small screwdriver, you just push on the blade. Keep in mind that if you program it to spin very fast, it might fly off if you don't screw it on. Okay. So in the kit, it comes with the plastic bag like this, and it has like 3 blades with 2 screws. I normally use the double blade like this, or you can use a single one if you're curious. So it's a way that we can test angle. Okay. Now, if you're doing the next exercise, you would then need to attach. Now, I think they also gave you an extra one, the blue one like this. That's fine too. Okay, so you can use that one. I personally prefer these because, and if you give it a lot of torque, you will wear out the gear. I think I must have gone through like maybe a few of these already, and they don't last a super long time. They do sell a higher quality of these with the metal gear, which costs more. But for a lot of the things that we use with Arduino, if you want to move little small robots, or if you want to drive something pretty simple, you can use these. Now, in that box that you saw earlier, you also have a DC motor. So the metal one is a DC motor. So this is more more useful if you wanted to build like a robotic car, something that you need to spin faster. So, and this needs to be powered on its own. Okay. Because if you power it through the Arduino, not very good. Okay. So you want to hook up a 9 volt to these guys separately, and then you wanted to connect it also to the board. Um, and they recommend that if you're using a lot of motors like these or these, you want it to have its own separate power source. Okay. Because if you power everything through the Arduino, you're going to find that you're going to be very limited. So if let's say that I'm using this for like the blade for the drone, and I'm using something else for the drone that's also a motor, you want to also have alternative power source outside of whatever that's powering your Arduino. So if you're using a 9 volt battery to power your Arduino, you want to use separate battery to power your motor. Otherwise, you're gonna use up a lot of the power from the 9 volt battery, and it doesn't last. So your drone might not even be flying that far before it dies. Okay. All right. So um, on the next one, you are going to use the potentiometer, like what we have seen in the last one. So you should have multiple of these. So you don't have to detach from the last exercise circuit. You can find additional ones. I think they give you like 3 or 4 of these. You will need a servo. Okay, these are called SG90. Okay, they come in black or blue, and then a few wires. So just to touch on what everything is real quick. Okay, so for the servo motor, servo, like we mentioned, it's used for things like small robots. You will also find them in CNC machine, and industrial servo is a little bit different looking, but the whole point inside, it would have, you look inside the clear case, you would see the gears turning, right? And it has like a small tiny board that understands instructions when you connect it. Okay, and then you would attach whatever that you need here. Sometime that will be a blade to push things. um, and then if you look at coffee mixers, a lot of these automated coffee mixer, they have servo motors in them. So servo motors are not made to rotate 360 degree. They're made to rotate between 0 to 180. Okay. You can have it rotate 90 degrees or 180 degrees and so on. And it needs this much of power. So now um, on the gear, when you, like I mentioned, if you give it a lot of torque, it will wear out the gear, and sometimes it'll just get stuck. So when it dies is when you're trying to give it power and it's not turning anything. It's because the gear inside is worn or stuck, and it happens, right? When I taught this in my C++ class, I think like maybe 2 or 3 students out of maybe 30 something students, they have to replace their motor. Okay. So here it talks a little bit about torque. I don't want to go in depth with this because, just keep in mind that this is a small motor and you want to give it enough torque. So your voltage should be approximately 5 to 7. When you give it a lot more power, you will break it. Okay. So that's all you need is about 5 to 7 volts. So when you connect it, the power wire, it would be red. Okay. And they follow the standard. So when you look at your servo, you would see red for power. Ground, you will often see black, brown. I've seen them in gray. So, but the darker color that will be brown, right? Black, brown, or gray for ground. Your signal pin, that's how it's going to receive the signal that's instructed. That's going to be yellow or orange. Okay, yellow or orange. Now, on the one that they gave you with the kit, instead of yellow or orange, that one, it uses a white. Okay, so those are the 3 wires, and they are female, so you just need to use your jumper wire to connect to it. So now with the potentiometer, like what we've seen before, it has 3 prongs, right? The one by itself is for the ground, and then the 2 outer, you're gonna have the 5 volts and the signal pin, okay, for the analog. We are going to use the Servo library that's built for Arduino. So you're gonna include servo.h at the top of your code. And now when you see servo with the capital S like this, we are gonna initialize or create an object called X. So you can name X anything, but you need to use servo as typed with the capital S. So what it's gonna do is gonna pull from the library so that, so that way you can create the object, okay? And then this will be the same name, whatever that you use for the servo to do something, and you will see this in the code. Now, once you name that X, right, in that case, let's say we call it X, we would say X attach Y. So X is the name that you use for calling the servo to do something. Y is going to be the pin that's attached to that servo. Okay, so that pin would be, pin 3, which comes from the white or the yellow wire. Okay, and then when we do an X write POS, so POS stands for the angle that you want it to go. So if I wanted 90 degree, I would put in 90. If I want 180 degree, I would put in 180. Okay? So it's just a position. That's what POS stands for. Okay? So for this one, it's super easy. You just need a breadboard, you need some jumper wires, you would need a potentiometer, you need a servo motor, and you need your Uno and its cable. Okay. So let me set up my port. And let me re-upload this. Okay, so you see, let me stop this so you can see with my camera. Okay, so the point is to hook it up so when you turn your potentiometer, you see how it's turning. And sometimes it's a little touchy. I tested this earlier. If your wire is loose, it's going to be doing this. It's going to jiggle back and forth. And then, so the point is when you turn it, it's supposed to rotate. And sometimes you got to check this too. Here. Okay. Now, can you hook it directly to the pin? You can. You can definitely hook it directly to the pin of the Arduino itself, but since we adapted the potentiometer, we have to make sure that we use a breadboard. So the motor, you can drive it, just, go to its pin. There are only 3 wires that you need, right? Okay. So the yellow or the white is going to go to its digital pin. The red is going to be for its power. That's going to be 9 volt. I think I see why now. Oh yeah, I'm using the black for this one. And then you're going to have a ground. So just like before, we want the two leg of the potentiometer to, one is going to be for signal and then one is going to be for power. Okay. And so what I did was I had connected to here for one of the leg, and then I have the red connected back to the Arduino because you want to control it, right? So you have to connect it back to the motor. And then the blue, I had used it for the 5 volt. And keep your potentiometer in the middle of your breadboard so you have room to set up the other stuff. Any question? Okay. So once we got our breadboard going and we put in our code, at the top, when you're using servo motor, you always want to say include servo.h, just like how we did include pitches.h, right? But we didn't have to make a file for this one. This one's already built into the library. Then here you are going to create an object called my servo. And we want to use servo with the capital S. So it's going to pull that from this library. So anything that you have to declare, you got to do that at the top of your code. So we made an object called my servo. So that way it will be global. It's accessible in the functions. Then the next is going to be our variable called pot pin. And this is going to be our analog pin for potentiometer. So we want to initialize that at 0 because analog is variance. So you want to give it a value here. So then if it needs to store, it's going to store that here. When it, for the next one, we're going to do the val variable. And this variable is going to read the value from the analog pin as you turn the potentiometer. So the pin that you connect for your potentiometer is the A0. That will be the 0 here. Let me correct my statement from the last one. Yeah, so that was the yellow or the white. In the void setup, we simply do an attach. Okay, so since we already named our object, this is like the X, right? My servo dot attach. And then we are going to put in 9 because it's going to be pin 9, where the digital pin 9 here. So this is for the potentiometer pin, and this is for the actual servo pin, which is digital 9. Then in the loop, we would bring down the val variable. It's going to store, right, the analog read of pot pin, which is whatever's read from the A0, it's going to store that in val. So when you rotate your potentiometer, you would see that. Okay. And then we need to scale it. So it needs to be between 0 to 180. Okay. So in the parameter, we would put val. And then we would do 0, 1023, 0, 180. Then we want to write whatever that was stored in the val. So that will give it a position based on the scale. And this is the millisecond that's going to wait for the servo to start going. And you want this small, otherwise you're going to have to wait a long time. And if it's going back and forth, that means that, you know, it might be that you have some loose things there. So as you can see, I can rotate it and it should go back and forth. Okay. Any question?
So it just moves depending on the value of the potentiometer?
Yes. So when you turn the knob, it's supposed to rotate the blade back and forth. Yep, there you go. Good job, David.
All right, cool.
That's what's supposed to do. Yeah, see how David is using the other one, right? So you can, yeah, that's a.
Oh yeah, they
that's
didn't
a little
include a
bit.
potentiometer, but luckily I had one in my toolbox, so.
Yeah, and you have to use alligator clip with that one, or you have to
Yeah.
solder it on. I had, you know, I had stripped down some wire. You know, I used electrical house wire for one, and because I made it. You know, I was trying to build a computer case where you can rotate a knob, and it opens up the case. And I was trying to drive it with these motors with the spring, and you know, it didn't work out too well because the case was kind of heavy. But yeah, I had to solder on my strip wire on that because it didn't stay very well there. But yep. I think the one that you're using works way better than the one that comes in the kit, by the way, because the one that comes in the kit, the knob is a little sticky. And if you guys are interested in that, you can probably find it online for a few dollars too. Very cool. Yeah. Okay. Good job. Any question with this one? So I'm going to move this to the side a little bit. Oh, I should have used a longer cable. Let me use a longer cable for the next one so I can show. Because some of the kit USB cable is very short and I can't. I already used my laptop only has 2 USB connection. One I already used for the camera, so it has USB-C for the other. So I have 2 USB-C and 2 USB-A. So okay. So the alternative code that you see on the bottom, this is what it's doing. Okay. Kevin said when I plug in the 5V pin, it turns off the Arduino. Yeah, you're supposed to have the 5V pin. Take out your, I didn't use a ground. Let me check. Yeah, I didn't use a ground on mine on that one. So it might be that you have, actually I did. I have a ground, a 5-volt, an A0, and a 9. So I think it might be something is opposite on your breadboard. Check your potentiometer pin connection. I mean the wire connection, and then these, because you might have something that's opposite there. So when it turns off, it prevents itself from being shorted. So there might be something that has the reverse polarity on that. My code isn't giving me an error message. What should I try to troubleshoot next? I would look at, first, you should touch your wire and make sure that they're tightly connected, because sometimes that won't move the motor as well, because these gets a little loose sometimes, right? Because sometimes they're cheaply made. And then also check your board connection on how you're connecting your positive and your negative on your board. Okay. And then you should try to turn the knob. So push down your potentiometer. Sometimes if that's loose, it doesn't rotate. Okay, so if you just want to connect the motor and see it rotate, right, this would be an option for E. What you would do is for the code, if you look at the code, you need to connect pin 2, 5-volt, and a ground. And then you run the second set of code and it's going to do this. It's going to rotate without using the potentiometer. So if I want something to rotate every so often, I can do this. Okay. So it does 90 and 180, you see that? So if your potentiometer is giving you a hard time, you can hook it up. And if you read your code, you would see that you would have a pin 3 for the white or the yellow. You can hook it directly to the board. A 5-volt for the red, and a ground, which is a black. Okay, and then you put it in here, you attach it to the board, and then you run your code. Okay. The potentiometer isn't supposed to sit flush to the breadboard, correct? I don't have it flush to the breadboard. If you have it flush to the breadboard, likely that it's bent on the bottom so it doesn't have the contact. I couldn't push it further than it is. So it should have like about 1 centimeter gap from the breadboard. I don't know if you can see that on the, like that. So check maybe it's bent on the bottom so it's not having contact. But you do want it to sit a little tight, like it's not falling off. Okay. Okay, let me open up the rotate code. So if you look at the second code, if you wanted to do that one, right, you can include the library. Your pin connection, your yellow or your white, goes directly into the Arduino pin connection, which is 3. Then we declare our object here. So this one is called Servo 1. So your object can be named anything that you want, but you want it to have some kind of meaning to your project. And we wanted to use Servo, which pulls from, you have to type it exactly like that with a capital S here, and then give it a name. So you can call it S1 if you want for the name, or like our case we saw earlier, X, right, or my Servo. Then in the setup, you simply would do the attach statement. So we would want to specify, and so if you already declare your digital pin here, then you can just call that variable, or you can just pass the value if you didn't declare it. Okay, but you should declare it. Okay, so we would do object name attach, which is a method, and then pass the variable. Then in our loop, we would have it write. So the first is it's going to write 0 degree to start, wait 1 second, then write 90 degree, wait 1 second, write 180 degree, wait 1 second, and just it's going to keep on looping as long as you give it power. Okay. So if you're looking at, like, you know, those I've seen Servo being used for like kids candy dispenser, right? If you're looking at like the dispenser, let's say if it needs to rotate to drop the candy, you can do that. You can make like a little machine that drop M&Ms and things like that. I've seen some project like that. It's pretty cool. So you can use a Servo for that. All you have to do is just to program in its angle, and then use this library, create an object, declare your pin value, use that pin value inside the attach. Because if you don't attach, you cannot write the angle to it. You have to attach it to write the angle to it. Okay. So I gave you 2 options. So if the first one, if the potentiometer is giving you a hard time and you're tired of troubleshooting it, then you can do the second one. You just simply, I didn't have time to do a diagram today, I'm sorry for it, but you would then attach pin 3 for the white, and then 5 volt and a ground for the red and black. And then you would attach it to this. And then you plug it in, run your code, and watch it go. You attach the plate on top. Okay. And there you have the basic servo operation. The reason why I'm showing you this is we will do a trash can project with our paper box with this. So, but we are going to use proximity sensor with it. So when you put your hand next to the sensor, the proximity sensor, it looks like little googly eye. It looks like a little 2-camera eye thing. Then it's going to rotate this and it's going to flip open the lid. Okay. And then when you take your hand out, it's going to put it down to the angle. So in that case, we would have to breadboard it and we would attach the sensor like what we see with the potentiometer wire with it. And then we would have to set this up, right? And for that one to fully work, we also need to have a 9-volt battery. I forgot to tell iMake Innovation Center to give you a 9-volt battery. But if you have a smoke alarm, right, you would also use a 9-volt battery there, or 99-cent store sells like $2 for $4. Those don't last very long, but it's good enough. I bought boxes of them. I brought some into iMake Innovation Center. So you get the idea. Or you can also use power bank to power some stuff too. So okay. All right. So what we've done today is that we mostly work with our potentiometer, and we also explored a little bit of servo using, potentiometer or without it. Okay, I'll stay on for questions. You can finish your lab. If you already finished, you can put in your name in the chat. And I'll be on until 4 if you have questions. Okay. Take a picture of your circuit. That's what you're going to need to upload for your lab. So we need to submit A, B, C, D, E. You're welcome. Okay, so for the lab, it says part A, part B is part C, is servo part C. Yeah, if you look at the old document, it only said A, B, C. So yeah, so do the part A was the, let me go back and show you. Okay. Part A was the theremin. Okay. And then part B is the photocell with the LED. And then part C is your, I don't know if I mislabeled it. Part C is your RGB with the potentiometer. And then part D is your servo. So all the 4 things that we've done, the theremin, the LED with the photocell. The third is going to be your RGB with the potentiometer and photocell, and then the servo, which is 4. Okay. Have a good weekend, everyone. I'll be on for a little bit if you have questions.